Welcome to the Explainer. So, today we are unpacking a seriously fascinating breakthrough in the world of autonomous systems. Look, if you've been building with AI lately, you already know that scaling from a simple single-turn chatbot to a persistent multi-turn enterprise workflow, it is incredibly difficult. And honestly, it's mostly because of the massive costs involved. So, today we're looking at a tool called Headroom. It's essentially the ultimate transit layer proxy, specifically designed to solve these critical bottlenecks of enterprise AI scaling. Okay, let's dive right into this. When you look at a standard AI debugging workflow without any intervention, a typical request pushes well over 65,000 tokens. That's a lot. And here's the crazy part. When that exact same workflow passes through Headroom, token consumption drops by an astounding 92%, down to just 5,000 tokens. This reveals something wild. Wasteful payloads, they aren't just a bug in your code. They're actually a fundamental structural flaw in how enterprise AI systems are currently operating.
Now, you might be wondering, if frontier models from providers like Anthropic and OpenAI can routinely process, 200,000 tokens, why are we suddenly hitting a wall? And that's a completely valid point. Yes, absolutely. These models have the raw reasoning capability to ingest massive amounts of data, but the economics of it, they're terrifying. Waking up to a massive API bill is pretty much every developer's worst nightmare. Because when you're running thousands of automated requests every single day, those input tokens are billed by volume. Combine that with massive inference latency, and your highly capable workflow very quickly turns into a totally unsustainable operational expense.
So here's our roadmap for today's Explainer. We'll be unpacking the hidden structural inefficiencies in autonomous AI workflows, starting with the AI token cost trap and the anatomy of context bloat. From there, we'll examine the proxy solution, precision context compression, how to cure prefix drift, and finally, the CCR retrieval paradigm. Let's jump into Section 1, the AI token cost trap. You see, to truly scale AI infrastructure right now, it's no longer about the raw reasoning power of these frontier models. We actually have to completely rethink the structural efficiency of our input data pipelines. To really understand why, just look at how agents manage state. Unlike your standard single-turn chatbot, autonomous systems operate in recursive execution loops. They observe their environment, execute a tool, read the raw output, and then iterate sequentially. But here's the catch. Cloud LLMs are completely stateless. Because of that, an agent's entire sequential history has to be constantly, repeatedly resubmitted with every single new iteration.
Which brings us to Section 2, the anatomy of context bloat.
So the crucial point here is exactly what happens when these massive sequential histories aggregate. Imagine a standard diagnostic session, right? Your agent runs a repository grep command, which returns thousands of lines of text. Then it formulates a curl command to test an endpoint. Well, on the very next turn, the payload has to include the original system prompt, plus that massive grep output, plus the intermediate reasoning and the new curl results. Over successive turns, this data aggregates geometrically. It just snowballs and spirals completely out of control. That is context bloat.
And what's genuinely shocking about this is how much of that aggregated payload data is entirely useless to the model. Analysis actually indicates that a staggering 85% of typical payload data consists of structural redundancies. We're talking about endless repeating HTML pagination links, deeply nested JSON schema keys, and just repetitive stack traces. Only a tiny 15% sliver of that massive token count actually holds the vital data required for reasoning. The rest is just pure waste.
All right, let's move on to Section 3, Headroom, the proxy solution.
Realistically, lowering costs means we have to shift our focus away from endless prompt engineering and start aggressively intercepting this bloat before it ever triggers an API billing event. And this is where Headroom steps in as a transit layer solution. And the massive selling point here, the thing that relieves so much developer anxiety, is that it requires absolutely zero hard-coded logic changes to your application. None. Operating as a completely silent proxy, you simply redirect your environment variables to localhost. It just sits invisibly between your app and the upstream LLM, flawlessly supporting both OpenAI and Anthropic payloads right out of the box.
This zero-host pollution architecture is achieved through a really clever polyglot structure. It perfectly balances Python, which handles the highly adaptable routing and machine learning components, and pairs that with high-speed Rust binaries for the performance-critical execution. It's the best of both worlds. Next up is Section 4, Precision Context Compression.
Now, using naive summarization tools in an enterprise context is incredibly dangerous. You can't just blindly chop up an API payload. Mathematically safe context compression requires actually understanding the exact operational modality of the data so you don't destroy vital technical workflow variables. And this brilliantly illustrates how Headroom's content router handles that. When it detects structured JSON or REST outputs, it routes them to a smart crusher module that strips out boilerplate and nulls while mathematically preserving the vital relational hierarchy. But if it detects raw source code, standard truncation would completely break it, so instead it routes to a code compressor. This parses the code into an abstract syntax tree, which safely collapses lengthy docstrings while preserving the exact function signatures and execution pathways.
The direct benefit of this systematically stripped data goes way beyond just saving on API costs. By removing the syntactic bloat while safely preserving the semantic intent, the model receives a vastly cleaner prompt. Without getting bogged down in distractor context, the LLM's attention heads can actually focus far more accurately on your core instructions. This directly and immediately improves its overall reasoning capabilities.
Moving right along to Section 5, curing prefix drift.
This leads us perfectly into solving a huge common frustration for developers. A lot of us assume that standard key-value caching from cloud providers will just automatically give us massive discounts on these multi-turn contexts. But in live enterprise environments, this caching structurally fails over and over again, and the culprit is prefix drift. You see, provider caching requires exact character matching. So if your massive log file contains even a single dynamic variance, like a 1 millisecond precision timestamp or a rotating session UUID, that tiny discrepancy triggers a full cache invalidation. Boom! You end up paying full price for that entire multi-turn context every single time.
But Headroom actively counters this vulnerability through its cache aligner module. Take a look at the contrast here. On one side, you've got a raw payload just riddled with volatile timestamps and rotating UUIDs. But on the other, the cache aligner has mathematically stabilized the output. It enforces deterministic ordering on JSON keys and actually masks those dynamic UUIDs before they ever reach the provider. By neutralizing prefix drift, this system basically forces consistent provider-level cache hits. It finally unlocks those massive latency and cost reductions you were expecting in the first place.
And finally, Section 6, the CCR retrieval paradigm.
This last module is super cool because it addresses a massive epistemological gap in the industry. Normally, aggressive context summarization is totally irreversible. If a proxy discards a variable to save tokens, the downstream LLM obviously can't recover it, which usually leads to hallucinated variables and failed execution loops. But Headroom completely solves this with the compressed cache retrieve, or CCR, paradigm. Here's how it works in 4 simple steps. First, the proxy aggressively compresses the payload locally, but hashes and saves the exact uncompressed data. Step 2, it forwards that compacted payload to the LLM alongside the hash and instructions on what was omitted. Step 3, if the LLM's reasoning engine decides it actually needs those granular details, it simply executes the retrieve tool using that specific hash. And step 4, the proxy intercepts this call and instantly returns the full local raw text. It is just brilliant. It bridges token truncation with 100% data recoverability, completely avoiding a latency-heavy round trip to your original database.
And, as you'd expect from serious enterprise infrastructure, Headroom maintains incredibly strict data sovereignty. It uses a local-first security architecture that explicitly prohibits any credential storage or payload logging. Plus, it integrates seamlessly. We're talking LangGraph execution loop compatibility, Cloud Code CLI wrappers, and it acts as a model context protocol server right out of the box. And that cross-agent memory store? It acts as a persistent operational brain for your local dev environment, automatically deduplicating successful logic paths across completely disparate sessions.
Which brings us to our final thought for today's explainer. Intelligent middleware context layers are actively transitioning from optional developer tools into non-negotiable enterprise infrastructure. As AI continues to scale from simple chatbots into fully persistent, autonomous workflows, managing that context bloat isn't just about saving a few dollars anymore, it's absolutely critical to performance. So my question to you is, if 85% of your AI data pipeline is just redundant bloat, what could your agents actually achieve if you finally gave them some headroom? Thanks so much for joining me on this explainer, and keep exploring.